Okay, so we are recording the chapter 9 practice activity. This is a question about a manager who wants to determine if there is a relationship between the years someone has been employed and the amount of sales they generate. As I said, we will input the X values in L1 and the Y values in L2. And the first question is to find the correlation coefficient. The correlation coefficient, this is how you can find it, guys. No one has an excuse not to get 100% on the assignment, guys, after doing this exercise. Well, we've done it already, but I'm going to do it again. Linear regression AX plus B. And here you go, you get R, which is 0.63. Okay, so let's put it aside. And there appears to be, it is positive, so you say, but I didn't say strong, guys, because 0.63 is not close to 1. It has to be close to 1 to say strong. So there appears to be a positive linear correlation between years employed and sales. Second question. Test for positive correlation between the years employed and the sales. I say test for positive correlation. As I told you last time, to test for positive correlation, that means the population correlation coefficient is greater than 0. Then your null hypothesis will be less than or equal to 0. And as I told you, you don't put where the claim is, you put always. If you are in the null hypothesis, you put correlation not significant. And if you are in the alternative, you put correlation is significant. Why? Because when rho is close to 0, that means there is no correlation, and the 0 is included in the null hypothesis. So this is the statement that you always put. If he asks you to test for negative correlation, then this one will be less than 0 here, and the other one will be greater than or equal to 0. If he asks you to test for correlation, he doesn't say positive or negative, then this one will be equal and that one will be not equal. How do you run the test? Very straightforward. This is one way to run the test. You go to stat, tests, linear regression t-test, guys. It's at the bottom. There you go. X list is in L1, Y list in L2. Don't touch the frequency. Now rho. Since you choose a greater than 0, make sure to select a greater than 0 here. And then hit calculate. Okay, you get the test statistic. As you can see, it is 2.158. And you get the p-value, which is 0.0339. There you go. Oh, I made a mistake here. I want to make alpha 0.01. Right here, you see alpha is 0.01. So it's still correct. Because if this was 0.05, it will be less than. So 0.0339, guys, greater than alpha, which is 0.01. Fail to reject the null hypothesis. If you fail to reject the null hypothesis, this is what you say always. This is what you select if you're doing the homework online. There is not enough evidence at the 0.01 level of significance to conclude that correlation is significant between sales and years employed. If, let's say, when you do the assignment, this was less than alpha, so then you reject HO and you say there is enough evidence at the 0.01 level of significance to conclude that correlation.
So basically, how do you find T again? I didn't see it.
Oh, T right here. When you run a linear regression t-test, it's going to show right here. Can you see the T?
I can't see the calculator. Do you go to stat? Where do you go?
You go to stat, tests, scroll up, and linear regression t-test.
Oh, okay.
L1, L2, choose the proper alternative sign. Since he says positive, choose the positive. If he says negative, choose the negative. If he says correlation, choose the not equal 0. And then hit calculate. Here you go. And look, this is the t sitting there. And that's the p-value. That's
Okay.
all you need.
And I had one more question. How do you know which one, which is in the claim, so we can say if there is?
Always the claim is in the alternative here. Always we're testing the alternative. So we don't put where the claim is. We put in HO, we put correlation is not significant. And in HA, we put correlation is significant. So if you fail to reject HO, you say there is not enough evidence to conclude that correlation is significant. If you reject HO, you say there is enough evidence to conclude that correlation is significant.
Okay.
All right. Now the next question, guys, he says, find the equation of the regression line. You can use this one actually for the equation of regression line. But look how he written the equation. He wrote y equals a plus bx. So you write ya equals a plus bx. And let's copy a and b and see if they match with this. Okay, let's see. Okay, what's A, guys? A, he says 37.916. And let's see what B is. 3.52. So you just plug in A and B by their values, and you get this equation. Okay, that's the equation of the regression line. Predict the sales in thousands of dollars if the years employed was 12. So he gives you X here, guys. You go and plug in X here. But before you plug in X, guys, equal 12 in the equation, go to the years and make sure that the 12 fall within the range of values. Well, the highest value is 15 and the smallest is 2. Since 12 falls between 2 and 15, so it's okay to use it in the equation. And that's when I plugged in and I got $80,000. Predict the sales in thousands if the years employed was 20. As you notice here for 20, guys, I said not meaningful to use in the equation. Let me tell you why. If you go to the range of values, you know 20 is way beyond 15, which is the largest value, so you don't apply it in the equation. So it has to fall within the range. So that's what I put. Not meaningful to find y. The last part, F, find the coefficient of determination r squared and interpret its meaning. Well, r squared, guys, is the square of r. If you don't want to use it off the calculator, it's already on the calculator. You can just take 0.632 and multiply by itself. So you get 40%, 0.4. Here's how you interpret r, guys. Please pay attention to the interpretation. You start, you change r to a percent, and you say, 40% of the variation of the y variables can be explained by the variation of the x variable. So 40% of the variation, what is the y variable called? Sales. So 40% of the variation in the sales can be explained by the variation in the number of years employed using the regression line. And this is for students who forget about r, how to show r and r squared. Again, if r and r squared values don't show up on your calculator screen, do the following. Press the second followed by the number 0 and then scroll down to diagnostic on and press enter twice. And that is the practice exercise. And let me take you to the assignment, guys, and show you it's very much the same.
Mr. Bozzi,
Yes.
I don't understand part C, like how you found the equation.
Okay, here you go. There are two ways to find the equation. We did the linear regression t-test, okay? You see where it says y equals a plus bx?
Yeah.
Okay, all you need is just plug in a and b by their values. A is 37.916, put a 37.916. And b is 3.53, just put b 3.53 and put it in here. Or look what you can do if you don't want to run the test. Clear, you can go to stat, calc, number 4, linear regression, ax plus b. AX plus B. It's different. It's AX plus B, but he swapped the A and B. Put the A by its value, which is 3.5329, and B 37.916. Plug them in here. A is 3.529, X plus B, and then you should get the equation.
Okay, thank you very much.
No problem. Okay, guys, watch here. Here is your assignment, and tell me if you have any questions before I wrap this up. So you put this in L1 and L2 and find R. That should be straightforward, just like we did. Then test for positive correlation. So what you need to test, guys, you need to test this. That's your null and alternative hypothesis. So you just run a linear regression t-test. And you're gonna get t, you're gonna get the p-value, and compare the p-value with alpha. If your p-value is less than alpha, you reject HO, and then you say there is enough evidence to conclude that correlation is significant. If p-value is more than alpha, you do just like in the practice assignment, there is not enough evidence to conclude that correlation is significant. C, find the equation of the regression line. It's y hat equals ax plus b. Predict the systolic blood pressure for someone who's 63 years old. You go to the values of X and check that 63 is within the range. If it is within the range, you plug it into the equation. If not, you say not meaningful to do it. Same thing for someone who's 72 years old. And you can see the last question, very much the same as the practice assignment. Find the coefficient of determination, R square, and interpret its meaning. Let's say R square, guys, turned out to be 70%. So this is what you say. You say 70% of the variation in the blood pressure can be explained by the variation in the age of a person or of an adult using the regression line. Any questions here? All right.